Hello, I'm Mrs. Schertz, and today I'm going to demonstrate how to take some indoor air pollution readings using POCKETLAB Air. So this is my POCKETLAB Air device, and I have my readings going here on my iPad app. And so it's been on for several minutes. And so let's go ahead and take data on your data chart here, data sheet, about the ambient, which is the background air pollution inside my home today. It's a Sunday afternoon. And one thing I noticed when I turned this on is that my indoor air quality was not great. And so I opened a window. Let's go ahead and take a look at the levels. So the first line here is my particulate matter 2.5. So it's 2.5 microns or more. Particulates is what this air pollution meter registers. And so I have the running total, which is in red, and then the average line of best fit, but is more of an average line that's in blue here. So let's get our averages. And so my PM 2.5 average is 73. That's the mean. And so on your data sheet 1A, PM 2.5 is 72 micrograms per meter square. And so this is a volume. So it's the volume of air. So per meter square, this is how many micrograms of particulates that are 2.5. The ozone is not calibrated. So the POCKETLAB company has not calibrated the ozone to be the reading in parts per billion to be accurate. But what we can see is a change. So right now our ozone mean, or our ozone reading, is 205 ppb, parts per billion. And so what we're really looking for the ozone is the change in the ozone. Then next we have our carbon dioxide, and its mean is 1,218. You can watch the red over here go up. So let me pull it up. It's this top one here. And if I blow into it, I'm going to do I'm going to respire out CO2. So you see this big spike up here on the graph in CO2 because I blew out CO2 from my lungs. And then the AQI, the air quality index reading right now, is based on the particulate matter reading. So not the ozone, but the particulate matter reading. And the AQI average right now is 153. So you're gonna write that as well for 1D, it's 153. That's actually not great. And I was thinking, well, why is my indoor air pollution kind of bad right now? Well, my son just cooked a bunch of bacon in the house. And so all of that particulate matter from cooking has created a lower or a higher air quality index and particulate matter in the air that is good. All right, so now let's go ahead and take a look at the air quality readings when I light a match. So I'm going to light a match. I'm going to hold it in front of the air pollution readings, and so I'm going to light this match. I'm going to hold it here. And we're going to notice, let's go back to our particulate matter, and it's covered up for you guys a little bit, so I'll put it over here. And so we have this match, and the match readings, actually I'm going to do it again because it's still coming down after I blew into it from the carbon dioxide readings. So I'm going to go ahead and put this up here so you guys can see it a little bit better. But the match itself is burning, right? You have a sulfur tip, you have particulate matter, and let me actually do this. Oh, there above, because I'm going to show you the smoke from the lighting of the match. Let me do it actually right in front of the meter. There we go. So right in front of the meter is where you're going to get the readings. There they spiked up. all right? So the PM 2.5 went as high as about 240 micrograms per meters cubed. So you can put on your paper that it went as high as 200 and actually I see it's 250. So 250, you can see the spike right here. Whoa, don't want to burn my hand. All right. The other ones, the ozone did not spike. Carbon monoxide did not spike. So the carbon monoxide and ozone readings, you can put down ozone as 175 parts per billion. You can put down carbon monoxide as 1407 parts per million, 1407. And then our air quality, you'll notice the air quality, the AQI went up and down because it's really measuring the particulates. So it spiked when I lit the match and it spiked at 300. So that's actually like hazardous air if it was 300, like for, you know, more than just the match being lit. So now I'm gonna blow out a match. And so let's take a look at our paper. So the match was lit, we have those level. And, oh, we're not gonna blow out the match. Next one, we're gonna light a petroleum wax candle and let it burn until the wax starts to melt. Okay, so now we're going to compare a regular candle with a soy candle. So I have here a regular Bath and Body Works candle that's made out of petroleum wax, and this is a soy wax candle. So this is made out of plants. This is made out of fossil fuels. And so we're going to check the levels of each of these while it's enclosed in this box. So let's go ahead and light our candle here. Okay, now initially our particulate matters are going to go up because when you light a match, you have all that smoke, and so you can see the level spiked. Up here, the top one is particulate matter. This third line down here, this carbon dioxide had peaked when I lit a match off to the side a minute ago when I had the video paused for a moment. And so now let's see here, we have our particulate matters kind of going everywhere here, but we're going to put it in a closed container. It can kind of mimic maybe an inversion later outside or just an enclosed space. And so we're going to take our measurements here. Now I have to be kind of careful I don't melt the top of my container. So I'm not going to do this for very long. So we're going to have here our levels of particulate matter and our ozone and CO2. So again, ozone is more of a comparison. What was the ozone before? What is it now? And that is not going to work because that is melting already. So let's go ahead and take a look at our levels before we took this off because it was melting. And so it got as high as 250 on the particulate matter. So PM 2.5 is 250 micrograms per meter squared. And then our ozone was about 340 parts per billion. And our carbon dioxide reading peaked here at about 2,000. So the carbon dioxide goes up in the closed container because we're burning fossil fuels, right? And so our carbon dioxide is going to get trapped here in this container. And so the carbon dioxide levels will go up because we're burning a fossil fuel here. All right. And I just burnt a hole in it. And then our air quality, our AQI, maxed out here at 300 when I put the lid on before it started to melt. So that is our numbers with a petroleum wax candle. All right, so now I'm going to go ahead and blow it out. We're going to see where our levels peak here. All right, so we're going to have our levels here. Let's check our particulate matter. Our particulate matter should spike. You can see that over here on the graph. Our particulate matters did spike. It went up to 250. And it's still kind of going up and down. If I hold it more above here, you're going to see it a lot higher. Our ozone was about 360. Carbon dioxide, when I blew it out, was about 1900, because once I released the lid here, the carbon dioxide that was trapped went out, so it's a little bit lower. And our air quality index maxed out again at 300 for the AQI. All right, so now let's go ahead and try this with a soy candle and see if our levels are any lower with the soy candle. So I'm gonna put my pocket back in here, my POCKETLAB. And I'm gonna go ahead and light the soy candle. And let's see if that makes a difference. So you're still going to get carbon dioxide readings because while you're not burning a fossil fuel with soy, you are burning a plant. And then when you burn plants, it's biomass and you're going to get carbon dioxide readings. And so you are also going to get some particulates because it's a plant. But are you going to get as much as the petroleum candle? So for this one, now we have a hole in here. It's going to let some stuff escape. So I'm going to try and block the hole so that we can get better accurate readings. I'll block it with the lid to one of the candles. And so we can get some consistency in our data. All right, so now that we have enclosed our soy candle, our levels here of particulates are at about 175, and it's still dropping a little bit less. It's actually, let's call it 150. So this is number 5A, 150 micrograms per cubic meter. Our ozone is about 375 parts per billion. And our carbon dioxide reading is going up because, again, we're still burning biomass. It's still going to release carbon dioxide, and it's going up and trapping more and more, but it's at about the same period of time. It was at about 4,000. So that's less than it was with the, and our AQI, it peaked at about 270 for the AQI. So those numbers are less with the soy candle versus the petroleum wax candle. So at the store, this is one of the reasons why when I buy a candle for my house, I buy soy more often. This was a gift. This is a petroleum one. So normal wax candles are going to be petroleum wax because it's cheaper than the soy one. So if you want to purchase something that's has less indoor air pollution, soy is a better choice, but it still has some, right? Okay, so now let's take a look at the next part here. So number 6, what else is burning besides the wax? So in a candle, right, it's the wick is burning. And what's a wick made out of? Paper, usually some sort of a fabric. So fabric or paper, some candles have a wood wick, which kind of really makes a nice ambiance. And so they're biomass, right? So they're going to burn, they're going to release pollutants as well. And really what's smoking right now out of my candle is from the wick. And so this particulate matter is going to be from a biomass. And for number 7, when you know about carbon dioxide, so anytime you burn fossil fuels, anytime you burn biomass, you're going to get carbon dioxide. So ozone, why does ozone increase when a candle's burn? What primary air pollutant must be emitted to create ozone, and how is ozone formed? So go back to your notes. What are we emitting here to create ozone? Now, you know, when you burn petroleum products, you're going to emit NOx. My POCKETLAB doesn't identify, it only identifies PM 2.5 and ozone, and carbon dioxide is not technically an air pollutant. It's a greenhouse gas for global warming. So we know that when we burn petroleum, we emit NOx. So that is going to combine with the scent. So the scent of this peppermint candle, this candy cane candle, is a VOC, a volatile organic compound. And so the VOCs plus the NOx are going to create ozone from a burning candle. All right, so we talked about number 9, what other pollutants are coming out. The next thing you're going to do is you're going to open up this document here. This is a long research report, and so your questions tell you where to look for the exact answers, because I know it's long and it's also difficult reading. So scientific research is difficult reading. So I helped you with the questions to identify where exactly to find the answers in here. All right, so do that, and we're done with the video part of this lab.